Last one is the percentage increase for one stock in a survey. So this is at individual level. The percentage increase for one stock in the survey. Like in your introductory post, you are asked to write the statistic about yourself. So that is at individual level. When we are looking at a statistic at individual level, remember that it is a variable. Okay, statistic at individual level is variable. So look at the difference. We had the question in a survey of 100 stocks on NASDAQ. The average percentage increase for the past year was 9% for NASDAQ stocks. So the average increase for all these stocks, that is parameter because it is related to the population.
Don't pee there.
All NASDAQ stocks. So every stocks in NASDAQ, that's population. 9% increase for the 100 stocks. That is about the sample. So it is a statistic. 100 NASDAQ stocks that you surveyed, that is, you took 100 out of everything. That's why it is called sample. And the last one is percentage increase for one stock. You have one stock and we are talking about the percentage increment on that. So it is just on that one, that is at the individual level. So whenever we are talking about the individual level, that is always called the variable. Any question up to this point? In this example, let's see what we have. Classify the variable as quantitative or qualitative. When we say quantitative, meaning it involves pure number, and qualitative means it is a categorical data. Nation of origin. When we talk about nation of origin, does it involve any number?
No.
No. So is it qualitative or quantitative?
Qualitative.
Qualitative. Okay. I'll just write QELI so you know that that's qualitative. B, number of siblings. Does it involve pure number?
Yes.
Yes. You'll say 5 or 3 or 4, right? So it is qualitative or quantitative?
Quantitative.
Quantitative. Quantitative. Quantitative is also called numerical. Remember that. Quantitative is also called numerical. And then qualitative is sometimes called categorical. Okay. Someone's microphone is on mute, so make sure you keep that mute. Whenever you're talking, you can unmute and talk to me. In C, grams of carbohydrate in a donut. How many grams of carbohydrate are there in a donut? If we look at that result, does it involve a number or a categorical value?
Number.
A number. What is
Quantitative.
Quantitative. Quantitative or numerical. Okay, now this is interesting. Look at the other one, D. In D, what is there in D? Number of football players jersey, right? You'll see a number there for sure. Number 18 or number 7, right? You'll see that number. What do you think of this number? Is that number a real number, a number in real sense? Like you can add and subtract. Okay, this player has number 5, this player has number 7. So if I add, I'll get 12. Can we do that?
No.
So this number is not the number which you can add, subtract, multiply, or divide, right? So is it qualitative or quantitative then?
Qualitative.
Qualitative. Qualitative. Very good. Next one, look at that. Number of unpopped kernels in a bag of a microwave popcorn. So you have the microwave popcorn and there are some of them which are unpopped. So can you count how many are unpopped?
Yes.
Yes, so qualitative or quantitative?
Quantitative.
Quantitative. Quantitative. Okay. Assessed value of a house. What is the value of your house? You're selling a house and they will give you some value. Okay, the price of your house is this much dollar. Is that a pure number, a qualitative or quantitative?
Yes. Is quantitative.
It is quantitative. Very good. Quantitative. Okay. How about phone number? Your phone number is 720-675 something. My
Let's
number
see.
is something like that. Can you add and get a new phone number?
No.
Have you
No.
ever seen that in real life? No, right?
No.
So is phone number qualitative or quantitative?
Qualitative.
Qualitative.
Qualitative. Qualitative. Very good. How about student ID number, your S number?
Qualitative.
Qualitative.
Qualitative. You cannot add or subtract, right? Any question on qualitative and quantitative variables?
No.
Very good, very good. When you start doing math, it will be fun like this. But when I'm just lecturing, I know that it's not that much interesting, right? So what we have seen here, I'm just going to go over this one more time. So in this example, we look at all the variables which are quantitative or numbers, and we classify them as discrete and continuous. So when you are talking about discrete, you are talking about the value which is not a decimal, but continuous, which can even take the decimal value, right?
Mm-hmm.
So the goals is scored in a season by a soccer player, it is just a number without decimal, discrete. Volume of water lost each day through a leaky fault, it can be 2.5 liter, 2.7 liter, and so on. It can take decimal value, continuous. Length of song, it can be like 2.1 minute, 2.2 minute, 2.3 minute, and so on. It also takes decimal value, so continuous. Number of trees randomly selected at Yellowstone National Park. The number of trees selected can be 10, 11, 12, and so on. It cannot have the decimal value, so discrete. High temperature on randomly selected day in Aurora, Colorado. It can be 72.3 degrees, 72.4 degree, and so on. So that is the continuous. But the point is scored in NCCA basketball game cannot be decimal value, so it is discrete. Is that clear?
Yes.
Okay, very good. Okay, let's work on this example now. Let's see what is given here and what we are asked to do. A health club is interested in knowing how many times a typical member use the club in a week. They decide to ask every 10th customer. Look at that, what I saw. Every 10th customer. When you see the word every, what we are talking about, can you tell me what is that?
Systematic.
Population?
Systematic sampling, right? When we decide to ask every 10th customer on a specific day, we are doing a sampling technique called the systematic sampling technique. Okay?
Mm-hmm.
So here we have the question to answer. What kind of sampling design is this? You already said, what was that?
Systematic.
Yes, systematic sampling. Okay. And then the second part is number of visits per week. Now, after you collect the data, you will get the data, number of weeks per visit. The number of weeks per visit can be like 5 visits, 6 visits, 7 visits, and so on. You cannot have decimal number of visits. I visited the club 2.5 times. Have you ever heard that?
No.
No.
No. So what type of data is this? First, it involves number, right? So if it involves number, is it qualitative or quantitative?
Quantitative.
Quantitative. Look at that. Quantitative. And then it does not involve any decimal value, so it is
Discrete.
Discrete.
discrete. So it is quantitative but discrete. Okay. Any question on that? You can ask question if any. Yes.
Yeah, I have an answer about number B. If you find this kind of question, do you have to answer quantitative, discrete, or just quantitative?
Either way it works. If you just say discrete, that's fine. If you just say quantitative, that's fine. But I'm giving you the whole perspective of this. So number of visits is quantitative, and you know that the quantitative data can be further classified into discrete and continuous. So I just want to make everything clear to you. But if you just write discrete or if you just write quantitative, I'm okay with that in the exam.
Thank you.
Yep. Thank you for asking that. Okay, let's work on this fifth example. What I'm going to do is I'm going to leave this on a screen like this. I want you to read these two problems and think of the answer for this. What we are looking for here is this. You have to look at the information and check whether the information is for the population or information is for a sample. If the information is for population, it is called the parameter. And if the information is for the sample, it is called statistics. So please look at these two problems for about 1 minute and think of your answer. I'll be back. Okay, what you came up with? What do you think for the first one? Is it statistic or is it parameter?
Statistic.
Statistic because it is related to the sample, right? Very good. How about the second one? Statistic
Parameter.
or parameter? Because it is related to the whole population, right?
Yep.
Okay, great. I think we have two more examples. Okay, sixth example. For each of the following variable, we have to determine the level of measurement. When I say level of measurement, we are talking about whether it is nominal. If you remember, nominal, it involves the categorical variable, right? The pure categorical variable. And when we say ordinal, in case of ordinal, so try to remember those four. Nominal, N,
Interval.
means just categorical. Ordinal can be ranked, okay? It can be ranked, but the difference cannot be calculated. Interval, it is also ranked, but the interval makes sense. And the ratio is the pure number. Okay, you have four of them. What do you think of gender? What do you think of gender? Is it nominal, ordinal, interval, or ratio?
Nominal.
Nominal, very good. I'll just write N, okay? Nominal. What do you think of temperature?
Interval.
Interval, we have done the exact same example in the previous class, right? When you do that lecture. How about number of days during the past week that a college student studied, like they studied for 2 days or 3 days or 7 days? What is that? It's a pure number, so it is ratio, okay? If it's a pure number, then it's a ratio. How about the letter grade earned in your statistics class? A, B, C, D, it's a rank.
Ordinal.
Did you say ordinal?
Ordinal.
Yes, that's right. Okay. Nation of origin?
Nominal.
Nominal. Movie rating?
Ordinal.
Ordinal. It's a rating, different doesn't make sense. So ordinal, very good. Volume of water lost or volume of water used by a household? How many liters? Say that again?
Interval.
No, volume of water, it involves a pure number, okay? We don't do any kind of ranking, so it's a ratio. How about year of a birth of a college student? You are born in 19, no, just kidding, 2000 something.
Mhm.
Nominal?
It's
No.
nominal,
Ordinal.
it's interval in fact, okay?
Okay.
Because the difference
Understood.
makes sense there. Highest degree conferred, like high school degree, bachelor degree, master degree, PhD, and so on. What do you think of that?
Is it
Ordinal?
ordinal? Ordinal.
It's ordinal because it's a rank and
Ordinal.
difference is not calculated there. I color,
Mhm.
color of I, what do you think?
Nominal. Nominal. Nominal.
Nominal, very good. Assessed value of house, your house is worth this much
Ratio.
dollar.
Interval.
Ratio, very good.
Ratio. Interval.
Ratio.
And time of a day measured in military time. We talk about that. What is
Interval.
time?
Is interval. Interval.
Interval. Very good. Very good. Okay. I think the Zoom session is going to end quickly. So we are going to move on to the last example. Okay. To finish it quickly. So if you look at this example here, this is based on the observation and experiment. Look at that. Psychologist is interested in whether the size of tableware like balls, plate, etc. influences how much college students eat. Okay, so he wants to study how much they can eat. He randomly assigned 100 college students to one group. That is, the first group is served a meal using normal size tableware, where the second is served the same meal but using a different table sizeware. That is 20% smaller than the normal. And he recorded how much food is consumed by each group of students. And you have to identify the following in this experiment. What is the population? What do you think is population? All students, right?
All the students, yeah.
Yeah, that's the population. Sample, he took 100 students, you can see. So sample is those 100 students, right? Out of all students, 100 students are taken. That is the sample. Experimental unit. What is our experimental unit? The 100 students to whom the tableware was changed, right? So experimental unit, the experiment was conducted on those 100 students. So you can say the 100 students. Or the students who participated. You can say students who participated. Students who participated. What is the explanatory variable? The variable that is influenced by the researcher. You can see the tableware size is reduced to 20%, right? For a group. So that is your explanatory variable, the size of tableware, because that is reduced, that is changed, that is influenced. That's why that is the explanatory variable, size of tableware. I hope you don't mind my handwriting today.
Not at all.
And the treatment, what is the treatment? You can see the treatment that they have done, how they have manipulated the variable. That is the meaning of the treatment, okay? The way they manipulated the variable is they make the size 20% smaller. Do you see that over there? Right? So 20% is smaller. That is how they manipulated. The treatment was making 20% smaller. Making 20% smaller. Really difficult to write here. And then the last one, response variable, they want to determine whether it influences how much the college student eat. So the response variable will be amount of food they eat, okay? Amount of food they eat. So that is the last example here. I know that the session is going to end very soon. And we are also almost done with our time. Thank you so much because you are so patient today.